How are you? I hope and trust you all doing good, like I'm doing good here. This morning we still going to continue with our lessons. Like I told you, Bronco is going to help you throughout the year for you to write your matric exams and pass. So if you are first time watching our channel, please subscribe as usual. You must like our page. You share it to many platforms, and you must also not forget to hit the notification bell so that we give you more content. So today we're going to talk about fundamental counting principle as part of probability grade 12. Fundamental counting principle, in a short way we call it FCP. FCP, fundamental counting principle, as part of your grade 12 work, which you are going to answer questions on. Now, one will ask, what is fundamental counting principle? Let's say, for instance, you have m ways of doing things, or m ways for an event to occur, and a second event occurs in n ways. So now, if a question is given, in how many ways can both or can all the event occur? Then now we will have to give our solution as m times n ways. It can occur in m times n ways. It's saying that if there are m1 ways for an event to occur, comma, m2 ways for a second event to occur, and m3 ways for a third event to occur, and so on and so forth. Then, if you are looking for the total number of ways in which all the three events can occur, we will just say m1 times m2 times m3, so that we will get our sample space in which all of them can occur. So we're going to take an example of what I'm talking about. Let's say, for example, a takeaway shop. A takeaway shop sells burgers, hot dogs, toasted sandwiches, and fish. Each of these is served with either chips or salad. Then the question asked, how many different choices of meals does this shop offer? How many different choices of meal does this shop offer? So in this case, we are going to look at how many different choices of meal does the shop offer. First, we have burgers, hot dogs, and then we also were told we have toasted sandwiches, and fish. Now these are the main course of the meal. Then now it's served not alone, it is served with either chips. So these are the main course, and the option number 2 or choice number 2, they said it is served with chips and salad. And the question is asking how many different choices of meals does this shop offer. In simple way, you can see the choice number 1, you have 4 choices to make. And choice number 2, you have only 2 choices. So in this case, your answer will be simply 4 times 2 choices. And therefore, you get how many choices? You get 8 choices. That is your answer. So you will get 8 choices in all. If the takeaway shop is selling 4 different meals, and then in each meal you can either go with chips and salad. Then if they are asking how many different choices of meals that the shop offer, you simply say 4 times the 2 that is given as another choice that you can choose from. Then your answer will be 8 choices. We are going to take a look at it from the screen here, so that we we see how the arrangement of the choices happened. So here we are going to answer using a tree diagram. They said the takeaway shop sells these meals: burger, hot dog, toasted sandwich, and fish and chips. So now we are going to take a close look at what is happening here. Now, after the main course, which is burgers, hot dog, toasted sandwich, and fish, they said each of these goes alongside with chips and salad. So now when I take a burger from that takeaway shop, I can either choose chips or salad. So now a person who can choose from there can get burger and chips or burger and salad. That is the combination. You choose a burger, you have a choice to choose chips or salad. So now in this case, when you choose a burger, you get a burger and chips or burger and salad. That is the only way it can happen. Now when you take a hot dog, you also have the other choice to choose chips and salad with hot dog. So now when you take a hot dog, you are going to get hot dog and chips or hot dog and salad. That is what you will get. If a person decided to take a toasted sandwich, you don't just take the toasted sandwich, it goes along with chips or salad. So now here you have toasted sandwich which goes along with chips. So you say toasted sandwich and chips. And also here you get toasted sandwich and salad. I hope you understand what is happening here. So when you come to fish, you also can go, fish can match with chips. So you get fish and chips, as we see in town all the time to buy fish and chips. Or you buy fish and salad. And this, when you count the number of meals or of choices that you can make, we have fish and salad, fish and chips, that give you 2. Toasted sandwich and salad, toasted sandwich and chips, that give you 4. Now when you go up, we are looking at the different possible meals you can get. We also have hot dog and salad and hot dog and chips. You can also get that combination. And then from there we can go to the last one, which we have burger and chips and burger and salad. So now when we count the number of meals that is available for you to choose from, you get 1, 2, 3, 4, 5, 6, 7, 8. In a simple way in mathematics, you don't have to write all this for me, but what you can do is to say 4 times 2, because you have 4 choices here and also you have got 2 choices here. So there are 4 ways in which the first one can occur, and there are only 2 ways in which the second one can occur. So when they ask you how many choices can you get, you just say 4 times 2, and that gives you 8 choices. And the choices are what I have explained to you. Is either burger and chips and burger and salad. That is, if you take a burger, you get chips or salad. If you take hot dog, it's either chips and salad. Anything that you take from the first 4, it goes along with chips and salad. So that is why we say in fundamental counting principle, if I have m ways of doing things and somebody has got n ways of doing things, if you want to know the total possible ways of doing things, you just say m times n. So m times n, and it gives you the total possible outcome. Now we move on to say, let me give another example from here. Let me give you another example. Let's say a gift pack can be made as follows. A gift pack. Let's say you have a birthday party and people attended it and you want to give them gift pack to go home. Or you have a gift pack can be made as follows. Can be made as follows. Now we have choice number 1. So we're going to follow the same thing. Choice 1, choice number 2, choice number 3, and then choice number 4. So in each choice, there are gifts that has been packaged for you to take along when you are going home. So here they said you choose one CD. You choose one CD out of, four possible different CDs. You choose one CD out of 4 possible different CDs. Choice number 2, you choose one packet of chips. Choose one packet of chips out of 5 different types. 5 different types. Now choice number 3, you choose one chocolate out of 12. Choose one chocolate out of 12 different chocolates. 12 different chocolates. Then choice number 4, you choose one type of fruit out of 3 different types of fruit. Choose one type of fruit out of 3 different types. So now you can see they have given you choices to make to form your gift pack. Okay, so here in choice number 1, when you go there, let's say there's a table and these are there. You say choose one CD. You know, a CD that we play for our music to be played. Choose one CD out of 4 possible different CDs. So when you go, you choose only one out of the 4. Here they said choose one packet of chips out of 5 different types. So you choose one out of the 5 different types. So here you have option number 3, or choice number 3 says choose one chocolate out of 12 different chocolates. And then when you go to table number 4 or choice number 4, they will tell you choose one type of fruit out of 3 different fruits. And the question is, how many different gift pack can be made? The question that the examiner will ask you, how many different gift pack can be made? A simple question. So we've got 4 choices here, choice 1, choice 2, choice 3, choice 4. Each of them come with something that you need to choose. So now the question is, how many different gift pack can be made? Now, when you are about to answer this question, in choice 1, you have how many possible different CDs that you need to choose from. You have 4 from choice 1. And here we got 5 from choice number 2, but we are choosing 1. Here we got 12 different chocolates, but you are choosing 1. And here we got 3 different types and you are choosing 1. So now the simple is, how many different gift pack can be made? So like I tell you the meaning of fundamental counting principle, if you have different ways of doing things, I have got different ways of doing things. When we want to know the total possible ways of doing things, then we will take mine and multiply by yours. So now there are 4 possible ways of doing things here. There are 5 possible ways of doing things here, and there are 12 possible ways of doing things in choice number 3, And there are 3 possible ways in doing things in choice number 4. So in here, your solution is as simple as A, B, C, D. Let me try to adjust and wrap off here. I hope you captured the question. So now we are just going to look for a solution. In choice number 1, we have 4 possible ways of doing things. So in your solution, you write just 4. That is in choice number 1. It's 4. In choice number 2, you have 5 possible ways of doing things. So you multiply by 5. In choice number 3, you have 12 possible ways of doing things. You multiply by 12. And in choice number 4, you are choosing 1 out of 3. So you've got 3 different ways of doing things. So at the end of the day, you take your calculator, learners, and you multiply 4 times 5 times 12 times 3. And that will give you 720 different gift packs. So they ask you how many different gift packs can be given. So you get 700 and what? 20 different gift packs can be given out. So this is what we call the fundamental counting principle. This is what we call the fundamental counting principle. So here, so boys and girls, like you saw how I did my solution. In choice number 1, there were 4 different ways in which a person can choose, or possible CDs that you can choose from. In choice number 2, you got 5 different types of chips you can choose from. In choice number 3, you got 12 different types of chocolate you can choose from. And in choice number 4, you got 3 different types of fruits you can choose from when you are making a package, a combo for a person. Now, in all this, if you want to know how many different gift package that can be made, it's just 4 ways times 5 ways times 12 ways times 3 ways. And then that gives you 720 different gift packs. That's what our question was asking you to do. So that is what we call the fundamental counting principle. So now what we are going to do now is possible questions they can ask you. Sometimes they ask you the fundamental counting principle with the repetition. So now when we say repetition, something is occurring or appearing many times. So that is what we call the fundamental counting principle with repetition. FCP with repetition. Now, so we're going to look at the example on the board. And if you look at the example on the board, it says a PIN code for a bank card must consist of 2 letters followed by 5 digits. And the digits start from 1 to 9. Remember when we talk about digits, it starts from 0 to 9. But now here they are saying 1 to 9. So you must take note of it. A PIN code for a bank card, we all use bank card. And before you can withdraw your money from the ATM, we normally use our bank card to insert into the ATM to get our money. Now the question is saying a PIN code for a bank card must consist of 2 letters. So followed by 5 digits. That is the arrangement. And the digits must be from 1 to 9. How many different codes are possible if the letters and the digits can be repeated? So we are dealing with the repetition now. So take note, my learners, take note, when we are dealing with repetition, the question tells you, and you must know how to answer questions on that. So now we are saying a PIN code for your bank ATM card must consist of 2 letters. Letters, we take it from alphabets, followed by 5 digits. And the digits must be from 1 to 9. 1 to 9. So now to answer these questions, they ask you how many different codes are possible if the letters and the digits can be repeated. Take note, underline the word repeated. So we are dealing with repetition. So if the digits can be repeated, how many possible letters and digits can be repeated? Let's see how to give our solution. They said 2 letters of alphabet, then followed by 5 digits. So now it means the password consists of 7 characters, because 2 from the letters of alphabet. So now here you can draw a small table like this. We have 2 from the letters of alphabet and 5, 1, so 1, 2, 3, 4, 5, 6, 7, because it's a 7 character password. Now they are talking about the repetition, letters followed by digits. Then the question is, how many letters are there in alphabets? We all know that from grade R there are 26 letters of alphabets, of which 5 are vowels and 21 are consonants. You must take note of that. So there are 26 ways in which the letter can occur, because they said each letter can be repeated. So even if you take A, it can be repeated 26 times. For now, we don't need which letter we are talking about. And then now we can take any letter of alphabet and it can repeat 26 times. So with the repetition is 26 times. The second letter can also repeat 26 times, because those are the number of letters in an alphabet, 26. So the first one, which is a letter followed by another letter, 2 letters, is 26, 26 because of repetition. Now, the next one is how many digits are there between 1 and 9. So you can start to say 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 digits in between the interval they give you from 1 to 9. You get 9 digits. So all of them can be repeated. So all the 5 numbers that they give you, or the digits that they give you, can also be repeated. So here will be 9, 9, 9, 9, 9. So each number that you can choose can be repeated 9 times. So in this case, your answer is going to be 26 times another 26, which you can say 26 squared. Then now you can go to times, because the 2 digits can be repeated in 26 squared, times 9. How many 9s are you seeing? 1, 2, 3, 4, 5. So 9 to the power 5. 9 repeating itself 5 times. That is your answer. So this is what you get, and you press your calculator. It gives you 39917 different codes. So if you are creating a password using this repetition, you're going to get 39917 different codes can be created for the bank customers. So those who are behind the scene in the bank creating your bank codes, this is the topic they learn in order to create the bank codes that we have in the individual bank codes that does not contradict one another. So you need to know how repetition is done. If they say repetition is allowed, then it means if there are 2 letters in alphabets, it's 26, 26. And then if there are 5 digits that must be chosen from 1 to 9, we know that when you count it, it gives you 9. So it will be 9 to the power 5. And when you take your calculator and do it, this comes to your answer. So we must take note of that, how repetition is done. Now, can we take another question and see how we're gonna go through it? I'm going to take another question and see how we're gonna go through different types of questions here. So now the solution is what we see on the board. Now we're going to look at where repetition is not allowed. the fundamental counting principle without repetition. Example, same question. A PIN code for a bank must consist of 2 letters followed by 5 digits from 1 to 9. How many different codes are possible if the letters and the digits cannot be repeated? So the underlying word here must be cannot be repeated. So that is what you are doing. Cannot be repeated. Now let's say I have my 7-character password to create from 2 letters and 5 digits from 1 to 9. Now they are saying that none of them must be repeated. So now if I have got 26 letters of alphabet, I can choose any one. So the first space here will be 26. I have 26. When you choose one, before you choose one, the letters of alphabets are 26. That is it. Now I have chosen one letter. So now when I move from 26, you go down by how many units? 1 unit, because you have chosen one of the letters out of the 26. But together the number of letters, the total alphabets we have are 26. So it's 26. Now they said you must have 2 letters. So if here is 26 and you go down by 1, here will be 25 because there is no repetition. I have 26 options. I choose 1, so it will be left with 25 in the second letter that I'm going to choose from. So that is the meaning of no repetition. Now I have got 9 digits because from 1 to 9 gives you 9 digits. Okay. So now out of the 9 digits, here will be 9 digits. Now I have chosen 1 out of the 9 digits. So now if I move from 9 going down, how many are left? Here will be 8 digits. Then I have to choose another one because I'm choosing 5 digits. When I choose another one, here will be 7 digits. When I choose another one, here will be 6 digits. And when I choose another one, here is going to be 5 digits. So if there is no repetition is allowed, it means the total number that are there in the digits is 9. When I choose 1, it left 8. When I choose 1, it left with 7. When I choose 1, it left with 6. When I choose 1, it left with 5. So here my answer is going to be 26 times 25 times 9 times 8 times 7 times 6 times 5. This is what you are going to get here. And that is what they have done for you on the screen. They said the letters cannot be repeated. There are still 26 ways in which the first letter can occur, but only 25 ways in which the second letter can occur. For the first digit, there are 9 ways, okay, in which it can occur. Now the second digit can only occur in 8 ways. The third digit can occur in 7 ways. The fourth digit can occur in 6 ways, and the fifth digit can occur in 5 ways. Therefore, the fundamental counting principle is 26 times 25 times 9 times 8 times 1 times 8 times 7, times 6 times 5. And the total answer is 9,828,000 different codes. So your final answer, you press it on the calculator and it gives you 9,828,000 codes. So we can make these codes for different customers in the bank if we are to use this approach. Okay, so this brings us to a closure for today. But before I go, I'm going to give one question whereby they will ask you to say whether it is repeated or repetition is not allowed, and then see if we can answer the question. So let's move and check one more further question, and then we can bring our lesson to an end for today and to be continued tomorrow. Now let's consider, let's say you are given this, consider the word we are dealing with mathematics, so let's say consider the word mathematics. Consider the word mathematics. So we have this word mathematics. Now the question will ask you, consider the word mathematics. How many, in fact, the moment they give you the question, they will tell you what you are supposed to do. So if you are to consider the word mathematics, now the question is asking how many possible word arrangement can be made, how many possible word arrangement, how many possible word arrangements can be made if, and then they tell you one, the letters may be repeated. The letters may be repeated. So now fundamental counting principle with repetition. If the letters may be repeated, number two, the letters may not be repeated. So now they said consider the word mathematics. How many possible word arrangements can be made if the letters may be repeated? Question number one. Number two, if the letters may not be repeated. So now this is going to take us back to where we are coming from. The letters may be repeated. So we will be looking at the repetition and not repetition. Okay. So now how many letters are there in mathematics in the first place? How many letters are there in mathematics in the first place? Let us count. Let us count 1, 2, 3. Okay, you can write it down. M, A, that is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So mathematics has got 11 letters. And they're asking you if repetition is how many different possible arrangements can be made if all the letters can be repeated. Since there are 11 letters that can be repeated, then it means we are going to have 11 times 11 times 11 times 11 times. Each letter can repeat 11 times. So in a short way, your answer will be 11 to the power 11. 11 to the power 11. Because M can be repeated, because M can be repeated 11 times, A can be repeated 11 times, T can be repeated 11 times. So in a short way, you can say 11 times 11 times 11 times 11, 11 times. You see that? So you simply write it 11 to the power 11 and then you press your calculator and you put your answer there. So when I press 11 to the power 11, it gives you a number that is so huge. So yeah, you can even leave your answer like that. The answer is 11 to the power 11. Okay. Now, going forward, they can also ask you how many different arrangements can be made if the letters may not be repeated. So here, may not be repeated is our underlying word. If they may not be repeated and I've got 11 letters in here, let's say I've got 11 letters in here, but the first one before anything happens is 11. The second one will have 10 because it will not be repeated. It goes down by 1. So here will be 9. That is the third letter. And then here will be 8. Here will be 7. And here will be 6. Here will be 5. And then here will be 4, 3, 2, and 1. So it's going down. If the first one is 11 and it's not repeated, it means the second one will be 10 to choose from, 9 to choose from, 8 up until you reach 1 in that case. So in that way, we can now call this as, when you are going to do this, you simply say 11 factorial. 11 factorial. And then that will give you your answer. So that is where we introduce the factorial notation. So this can be called 11 factorial because it's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is going to be your answer. So instead of you to say 11 times 10 times 9 times 8 times 7, just press 11 and go on the calculator and press the factorial notation, which is on the far right corner there on the up. When you press 11, then you go to shift, then you press the factorial notation there, just below the cursor key, that round bottom, the bigger one, you will see something there as x factorial like this. You press it. So you press shift 11, then you press shift and then press the factorial key, and then it will give you your answer, which is 3 is a bigger number, 9, 9, and then you write 1, 6, 8, 0, 0. So if there is no repetition, then the number of possible arrangements of letters that can be done in mathematics will be this number. So this is simply means 11 factorial simply means 11 times 10 times 9, you go in that way, times, you can also check with the calculator, times 8 times 7 times 6 times 5 times 4 times 3 times 3 times 2 times 1, and then it gives you the same answer as 11 factorial. So this brings us to the end of our lesson today. We will come again tomorrow and give you more update on factorial notation. Factorial notation, which I've just introduced here, to say 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then instead of you to write it long way and multiply it through with the calculator, you simply say 11 factorial. When there is no repetition, it's going down by 1 unit. And that one, when you multiply the numbers, you can simply write it as, you count the numbers that are there in the word in mathematics, and then you just put your factorial notation because there is no repetition, and that will give you this number. So we bring our lesson to an end for today. I hope you have understood the concept fundamental counting principle. So if I have 2 ways of doing things and you have got 3 ways of doing things, the number of possible ways we can do our things is 2 times 3, and that will give us 6 possible ways of doing things. So you must just love fundamental counting principle. We are going to do more lessons so that by the time you go to the exams, you are familiar with what we are doing. For you not to be finding yourself wanted, subscribe to our YouTube channel, and like and share with other people in other schools so that we can help each other. We'll see you tomorrow. Have a good day. Love you. Bye-bye.